All right, guys, Mr. Bowers here with Mr. Bartlett. I'm going to go through one more section here on the cumulative review, thermochemistry, just a few problems. Mr. Bartlett will
Our legs keep touching, so I'm just going to move away.
Mr. Bartlett will resume with gas laws, and you should be pretty good to go with acids and bases, but we'll touch on that too. All right, so in the thermochemistry section, we haven't done this for a while. We're looking at exothermic versus endothermic processes. Remember exo, like exiting. So energy is exiting, heat is exiting. I say heat exits. Look at your vocab. It's all on there. And here we have heat enters. So if you think about exothermic, if heat is exiting, this would feel hot to the touch. This is absorbing heat. So it's going to feel, cold. All right, thermal equilibrium is kind of a complex topic, but not too bad. If you think back to our hot metal lab, the metal was very, very hot. The water was room temperature. When they got together, they met somewhere in the middle, closer to room temperature than the hot metal. Thermal equilibrium is just when you mix two things that are different temperatures and they reach equilibrium, which is kind of just the stable, I'll say stable temperature. So let's say you have 50 degrees Celsius water, you pour it into 100 degrees Celsius water. What's the equilibrium going to be? Halfway, right? 75 degrees Celsius. That would be with equal amounts. Does that make sense? All right, so 17 is very straightforward. I'm not going to do 17 for you guys. If you look at it, you're just doing QMCAT. We spent a lot of time with QMCAT. You're really just plugging in numbers and hitting equal on your calculator. Make sure your units cancel out. I am going to do number 18 with you, though. Number 18 looks at hot water cooling down. Gives you the mass of the water, gives you a specific heat. This is also a QMCAT problem, but it's asking for a final temperature. So as you look at this, Q is energy. See how this is in kilojoules and this is in joules? That already tells me I'm probably going to need to do a conversion. We're given 1,400 grams. That's a mass. This is a Q value. Q is energy. We're given an initial temperature, and we're given the specific heat, which is a C. It's C from your equation. So I'm looking for my final temperature. I'm going to go ahead and set it up. Rearrange the equation or just go with it, Mr. Bartlett?
I prefer rearranging the equation, but it's up to you, Mr. Bowers.
All right, so if I was to rearrange the equation to get delta T on one side, how would I do that? So I'm going to go ahead and divide both sides by MC. But then remember, delta T has meaning. Delta T means temperature final minus temperature initial. So that's kind of crazy, right? All right. Let's go with that and start plugging in some stuff. So I have 191 kilojoules of energy, which is 191,000 joules of energy. On the bottom, I have M for mass, which is 1,400 grams. And I also have the specific heat, C, 4.184 joule per gram degrees Celsius. And I'll have that equal to delta T. Should I leave it as TF or minus TI? What would that do? Let's go ahead and find delta T, and then we'll talk back about what I'm doing here in the middle. So I'm going to use my calculator. plug that in. If you look at your units and things that are canceling out, grams and joules cancel out. I'm left with degrees Celsius, which is what I want to be left with. All right, so calculate 191,000 divided by 1,400 divided by 4.184. I know I do my math a little weird. I could have used parentheses, but I'm lazy. All right, so I get 32.6. Bye, Mr. Napper. 32.6 degrees Celsius. That is my delta T. So how does that relate to TF minus TI? Well, if I start at 85 degrees Celsius and it changes in temperature 32.6 degrees Celsius, how could I use that information to find out what my final temperature was? So I guess the question is this temperature my initial or my final? So if I have TF minus TI equals 32.6 degrees Celsius, that's kind of where I need to go here. So subtract, right? 85 minus 32.6, is that right? 52.4, you guys good with that? All right, so 52.4 degrees Celsius is my final temperature. All right, thanks again. See you guys on Wednesday for our cumulative.